My name is Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today we're going to talk about how to change your nervous system for the better. As you recall, your nervous system includes your brain and your spinal cord, but also all the connections that your brain and spinal cord make with the organs of your body, and all the connections that the organs of your body make with your brain and spinal cord. Now, this thing that we call the nervous system is responsible for everything we know, all our behavior, all our emotions, everything we feel about ourselves and the outside world, everything we think and believe. It's really at the center of our entire experience of life and who we are. Fortunately, in humans, unlike in other species, we can change our nervous system by taking some very specific and deliberate actions. And today, let's talk about the different kinds of plasticity that are available to us, because those will point directly towards the type of protocols that we should engage in to change ourselves for the better. There is something called representational plasticity. Representational plasticity is just your internal representation of the outside world. We know that, for instance, if I want to reach out and grab the pen in front of me, that I need to generate a certain amount of force, so I rarely overshoot. I rarely miss the pen, okay? So our maps of the motor world and our maps of the sensory world are merged. The way to create plasticity is to create mismatches or errors in how we perform things. And this, I think, is an amazing and important feature of neuroplasticity that is highly underappreciated. The way to create plasticity is to send signals to the brain that something is wrong, something is different, and something isn't being achieved. Errors and making errors out of sync with what we would like to do is how our nervous system is cued through very distinct biological mechanisms that something isn't going right, and therefore certain neurochemicals are deployed that signal the neural circuits that they have to change. So let's talk about errors and making errors and why and how that triggers the release of chemicals that then allow us to not just learn the thing that we're doing in the motor sense, play the piano, dance, etc., but it also creates an environment, a milieu within the brain that allows us to then go learn how to couple or uncouple a particular emotion to an experience, or better language learning, or better mathematical learning. It's a falsehood that everything that we do and experience changes our brain. The brain changes when certain neurochemicals, namely acetylcholine, epinephrine, and dopamine, are released in ways and in the specific times that allow for neural circuits to be marked for change, and then the change occurs later during sleep. Basically, you need a certain cocktail of chemicals released in the brain in order for a particular behavior to reshape the way that our brain works. So the question really is, what allows those neurochemicals to be released? Today we're going to talk about the other chemicals in the cocktail, in particular dopamine. And we're really going to center our discussion around this issue of making errors and why making errors is actually the signal that tells the brain, okay, it's time to change, or more generally, it's time to pay attention to things so that you change. And I really want to distinguish this point really clearly, which is that I'm going to talk today a lot about motor and vestibular, meaning balance programs, but not just for learning motor commands and balance, but also for setting a stage or a kind of condition in your brain where you can go learn other things as well. So, because I think most people understandably get frustrated, like they're trying to learn a piece on the piano and they don't know, they can't do it, or they're trying to write a piece of code, or they're trying to access some sort of motor behavior and they can't do it. And the frustration drives them crazy and like, I can't do it, when they don't realize that the errors themselves are signaling to the brain and nervous system, something's not working. And of course, the brain doesn't understand the words, something isn't working. The brain doesn't even understand frustration as an emotional state. The brain understands the neurochemicals that are released, namely epinephrine and acetylcholine, but also, and we'll get into this, the molecule dopamine, when we start to approximate the correct behavior just a little bit. And we start getting it a little bit right. So what happens is when we make errors, the nervous system starts releasing neurotransmitters and neuromodulators that say we better change something in the circuitry. And so errors are the basis for neuroplasticity and for learning. And I wish that this was more prominent out there. I guess this is why I'm saying it. And humans do not like this feeling of frustration and making errors. The few that do exceedingly well in whatever pursuits they happen to be involved in. The ones that don't generally don't do well. They generally don't learn much. And if you think about it, why would your nervous system ever change? Why would it ever change? Unless there was something to be afraid of, something that made us feel awful will signal that the nervous system needs to change, or there's an error in our performance. So it turns out that the feedback of these errors, the reaching to the wrong location, starts to release a number of things, and now you've heard about them many times, but this would be epinephrine. It increases alertness. Acetylcholine, focus, because if acetylcholine is released, it creates an opportunity to focus on the error margin, the distance between what it is that you're doing and what it is that you would like to do. And then the nervous system starts to make changes almost immediately in order to try and get the behavior right. And when you start getting it even a little bit right, that third molecule comes online or is released, which is dopamine, which allows for the plastic changes to occur very fast. Today, we're really talking about how to tap into plasticity through the completion of a task or working towards something repetitively and making errors. The ultradian cycle says that for the first 5 to 10 minutes of doing that, your mind is going to drift and your focus will probably kick in, provided that you're you're restricting your visual world to just the material in front of you, something we talked about last episode, somewhere around the 10 or 15 minute mark. And then at best, you're probably going to get about an hour of deliberate kind of television learning in there. The mind will drift. And then toward the end of that, what is now an hour and 10 or hour and 20 minute cycle, your brain will start to flicker in and out. You're trying your best to accomplish something and you're failing. You want to keep making errors for this period of time that I'm saying will last anywhere for about 7 to 30 minutes. It is exceedingly frustrating, but that frustration, it liberates the chemical cues that signal that plasticity needs to happen. And it is the case that when we come back a day or two later in a learning bout after a nap or a night or two of deep rest, then what we find is that we can remember certain things and the motor pathways work. And we don't always get it perfectly, but we get a lot of it right, whereas we got it wrong before. So that 7 to 30 minute intense learning bout, specifically about making errors, I want to really underscore that. And it's not about, as I mentioned before, coming up with some little hack or trick or something of that sort. It's really about trying to cue the nervous system that something needs to change, because otherwise it simply won't change. I think everyone could stand to enhance the rate of learning by doing the following. Learn to attach dopamine in a subjective way to this process of making errors, because that's really combining two modes of plasticity in ways that together can accelerate the plasticity. In other words, failing repetitively, provided we're engaged in a very specific set of behaviors when we do it, as well as telling ourselves that those failures are good for learning and good for us, creates an outsized effect on the rate of plasticity. It accelerates plasticity. Now, some of you might be asking, and I get asked a lot, well, how do I get dopamine to be released? Can I just tell myself that something is good when it's bad? Well, actually, yes. Believe it or not, dopamine is one of these incredible molecules that both can be released according to things that are hardwired in us to release dopamine. Again, things like food, sex, warmth when we're cold, cool environments when we're too warm. It's that kind of pleasure molecule overall. But it's also highly subjective what releases dopamine in one person versus the next. So everyone releases dopamine in response to those very basic kind of behaviors and activities, but dopamine is also released according to what we subjectively believe is good for us. And that's what's so powerful about it.